All right. So this is the second exercise, the practice exercise from that page 403. It says tennis balls are usually filled with air or N2 gas to a pressure above atmospheric pressure to increase their bounce. If a particular tennis ball has a volume of 144 centimeters cubed and contains 0.33 grams of N2 gas, what is the pressure inside the ball at 24 degrees Celsius? So again, just going to first kind of list out the variables or whatever. We've got a volume of 144 centimeters cubed. We've got, so the 0.33 grams of N2 gas, it's grams, that's actually the variable N because we can turn grams into moles. So it's 0.33 grams of N2 gas. And we're actually we're gonna want that in moles. So we're gonna turn grams of N2 gas, so nitrogen is 14, so it'd be 28 grams of N2 gas for 1 mole. And this kicks us out something like 0.012 moles of N2. All right. And then it says the temperature is 24 degrees Celsius, which add 273 kicks us out, what is that? 297 Kelvin. All right. And what is the pressure? So we're looking for pressure, right? So if we look at what we have, again, we've got volume, number of moles, and temperature. We're looking for pressure. So this is a Pivnert problem. We have R, the constant. We're going to use a constant that has some of this stuff in it if we can. So if we look at our R constant, we've got volume in centimeters cubed, temperature in Kelvin, and moles. So volume in centimeters cubed. There is no volume in centimeters cubed. So we're going to look and see what we can turn centimeters cubed into in volume. So here we can go centimeters cubed to milliliters, and then we know we can turn milliliters to liters. So that's what I'm going to do. So I'm going to do centimeters cubed and milliliters is the same, so it's 144 milliliters. And then I'm going to convert it to liters by moving it 3 to the left, so 0.144 liters. Okay. So if we have liters, K, and moles, we can use the first one here with the liters atmosphere, the 0.0. So we're going to use 0.08206 liters atmospheres over moles K. That. Okay. So now we're just going to plug those into Pivnert. So we get pressure, what we're looking for, we don't have that. Volume, 0.144 liters. Number of moles is 0.012. The R factor we're using is the 0.08206 liters atmospheres over moles K. And our temperature is 297 K. So we multiply these, divide by that, we get a pressure of 2.032, which significant figures would be 2.0 atmospheres. Okay. Yeah. So there's the answer. Now there with the Pivnert problems, there can be, so this is a potential alternate or trip up type of setup. Okay, and that's where, so they can use density. So density is mass divided by volume. So, and you can convert mass into moles or moles into mass. So it's essentially mole over volume, or N over V is density. Okay, so if they give you a density, it can actually be done in terms of N over V, which, then like to convert the mass, the molar mass, the moles like that. But basically, if you take Pivnert, okay, and you rearrange, so if you're solving for pressure like we were here, so you get like pressure equals nRT over V. Okay, if you look, N over V is density, and the density to turn from mass to moles, you would take like the mass and you would do molar mass equals 1 mole, right? To turn from mass to moles. Okay, so the N is essentially your mass. This thing right here is N. So N is the mass divided by molar mass. Okay, so this, hold on. So this part right here, converting mass to moles, like that can go in for N. All right, so if we take this, there's a couple of ways that we can rearrange this. One is N over V is density. So you could have pressure is density times R times T. That's one way. The other way is you could have this pressure equation, again here, or you could have the pressure equation, and if they gave you the mass, you could actually have the mass divided by the molar mass, RT, over volume like that as well. Like either way would actually be a way that they could do. It's a way that they can do a Pivnert problem, but give you the information differently to make it look like you don't have everything you actually have. So like if they give you density instead of number of moles in volume, you can actually do it like this. Okay, or if they give you the mass instead of the moles, you can convert mass to moles and then plug in. I mean, you kind of knew that already, probably, I'm sure, but just something to be aware of. All right. Okay, so that's it for this problem.